So let's look at a different way that we can utilize the Ratchford-Rice equation or a multi-component flash drum. So just to remind you, here is the equation for the Ratchford-Rice equation for a multi-component flash drum. It's dependent on the K values of each individual species. It's dependent on the Z values, which is the mole fraction in the feed, and also the variable V divided by F, or V over F. And when all of this equation here is satisfied, all equals 0, and we have a proper solution to our flash drum. Well, let me point out something. These K values, they all depend on the temperature and the pressure, meaning that if the temperature changes, the K values change, or if the total pressure changes, the K values also change. So there's a relationship between the K values and the temperature and the pressure. So we may be given problems that stretch a little bit how we go about using this equation. So we've done in class, and we've shown some previous video how we might go about solving it if we're given the Z values and we're given some information on the temperature and the pressure to calculate K values, and then we solve for V over F. But that's not the only way we might utilize this equation. Sometimes we might actually have to solve for the K values. So we might be given V over F, and we might be given the Z values, and we might have to actually calculate the K values to satisfy this equation. So when would this be the case? Well, it might be a case where the temperature or the pressure is unknown. Here's an example where we're given the flow rate coming in, and we're given the composition of this feed. We're given the V and the L, how much those are flowing each other. We're given the total pressure within this flash drum, but we don't know what Xi and Y are, and we don't know what the temperature is, and that's what we're asked to find here. So how do we do this? Well, we need to use this equation up here, the Ratchford-Rice equation, to do that, but we have to find a solution such that this whole thing on the left equals 0. And to do this, we can't go about solving for V over F because, well, that's given to us. Instead, the unknown variable in this equation would be the K values. We know everything in this equation except the K values. Well, what do? Well, the K values depend on the temperature. So here, assuming that Raoult's law applies, the K values are dependent on the vapor pressure and the total pressure. So if I know the vapor pressure species I, just divide it by the total pressure, I get the K value for assuming Raoult's law applies. How do we get the vapor pressure? Well, we can use Antoine's equation. So we can get these vapor pressure from Antoine's equation. Well, Antoine's equation is just simply a function of the temperature. So if I know the temperature, I calculate the vapor pressure from Antoine's equation, plug it back into here, and to get a K value, I know the total pressure it's given, and then I can plug it back into here and see if it satisfies this equation. And it's basically an iterative process here that I'm going to follow. I'm going to guess a temperature, from there calculate the vapor pressure, then I'm going to calculate the K values, then I'm going to plug them back into here and see if this equation here on the left equals 0. If it does, then I have the right temperature. If it doesn't, then I need to guess a new temperature and then calculate new vapor pressures, new K values, plug it here and here to see if it solves this equation, the Ratchford-Rice. The whole crux of all this, again, is making sure that the Ratchford-Rice equation is satisfied, where everything on the left is equal to 0. And I just keep going through this procedure until I find the right temperature such that vapor pressure, which gives me K value, which plugs into here, gives me a Ratchford-Rice, that everything on the left equals 0. Once I've found that right temperature, then I can go ahead and use my other equations that are for multi-component flash drums to solve for Xi and the Yi values. And we could do a similar setup here if we were, for instance, asked to find the pressure. Well, in this case, K value depends on the total pressure, so I might have to iterate on the total pressure or guess the total pressure such that the Ratchford-Rice equation is satisfied. Again, just remember, when we're dealing with multi-component flash drums, we have to make sure that the Ratchford-Rice equation is satisfied. So we need to realize or try to identify which variables we don't know, and then try to find out those unknown variables in this equation so that this is everything on the left equals 0. And when we do that, we can go ahead and solve multi-component flash drums in various design settings, whether they're given information about the feed and we're asked to find the outlets, or maybe we're given information and we're asked to find the temperature, or maybe we're asked to find the pressure, whatever it is, we're just going to use these equations here.